right? I widened that out, but I didn't do it here. I think we did perimeter already for that problem. Just not area. So for the area, we're multiplying those together. 2y times 3y minus 5. So this is going back to our polynomial operations. We would distribute the 2y to everything. We're multiplying like bases, so we have to add the exponents. And then multiply 2 and negative 5. So that would be your area, 6y squared minus 10y. If we actually knew what y was, the value was, we could find the numerical answer for the area, but we don't need to know that.
So area is multiplying and perimeter is opposite.
In general, yes, but perimeter could also be multiplying depending on how you write it. So perimeter is adding up all the sides, or 2L plus 2W. So either or. Right, for number 5, so this should look very familiar because we were just doing this in our last unit. Solving for a specific variable. There are 2 different ways you could go about doing this. One would be get rid of your 2L by subtracting on both sides. Rewrite. So we have P minus 2L equals 2W. And then divide everything by 2 so that we can simplify to get P over 2 minus L equals W. That would be one way. You don't have to write the second one, but I'm going to. You could have also started off by dividing everything by 2. I don't think we did this, but it would work the same. So we would start off P over 2 equals L plus W and subtract L. Get the same thing either way. As long as you divide everything. If you don't, then you don't get the same answer. Okay. Questions on that one? Make sure your names are on your answer sheet, and then you guys can pass those forward, and I'll collect them from the front tables. Finish, but they need to be done before the end of class, and I need them before end of class. What I did with it is a better question now. In the future, I'm just going to take them as is. So make sure that you're writing these in the time period that I'm giving you. These are just informative grades. Anyway, just pass them forward. And then you can write those from now on. Out your pink sheet from last class. That will be a good reference for what we do today. If you didn't finish, some of the references may not make sense, but as I said before, that is your reference paper. So some of the examples you see may look similar to the ones on the pink sheet. You should also have these notes in front of you. Bless you. when it printed, not all the pages printed for whatever reason, so you have like the inserts and the actual thing. If you want to re-staple them all together, you can, but they're out of order. Right, so let's recap. So last class was like explorative domain and range, so you can kind of get used to it. Now we're going to actually take the notes on it. What is the domain, Otis?
X values.
Or X values. What are some other words that we could exchange those for? Independent variable. Or what else? One other word we could exchange this for. Input. Right, so then our range would be opposite. Y values. The dependent variable. And the output. Right? So, I didn't specify this, but when we were looking at the two different domain and range before, so the very first domain and range when we were doing relations and functions, those were discrete because they consisted of points that were not connected. And then last class we were dealing with continuous functions because they would be connected with one smooth line or curve. So how we write the domain and range depends on is the function or graph discrete or continuous. So a continuous function may have points when the function crosses or touches the x-axis or y-axis. We're going to fill this in, but then we're not really going to talk about it today. That'll be like next week. When this occurs, the function has a y-intercept, or an x-intercept. So you'll see as we go through some of these examples, it'll have a space for that. We'll come back to those. Yes. Make a pass. So let's go through some of these examples, starting with example 1. First, would this be a discrete or a continuous function? Notice.
Discrete.
We know that because they're random ordered pairs, points that are not, it doesn't look like a line or a graph or anything like that. So if you want to write that off to the side just so you know it for the future, you can, you don't have to. So when we write our domain and range for discrete functions is how we were doing it with the relation piece. Least to greatest in set builder notation, so your curly brackets. But just the numbers themselves. So -4, -2, -1, 1, and 3. We would not say this is from -4 to 3 because there are points in between there where this does not touch or hit. So then what would the range be least to greatest?
-4, 2,
again, these are no repeats, only list them once. Is this a function? Yes. We don't have any repeating x's that go to different y values. I circled no, but said yes. Questions on that one? Yes.
There's still a part where it's in a graph.
Oh, I forgot about that. That's probably why this is what about. Yeah, disregard that part right now. Because that's dealing more with our x and y intercepts, and we're going to go more into depth, so we don't need to know that piece of information right now. All right, so let's skip the you try, go on to example 2. This is which type of graph? Oh, so example 2 is on the inserts, not the stapled, but the other sheets of paper. And the inserts have page numbers at the bottom, just in case. And this is page 2. Okay. So for example 2, should look like this. Is this discrete or continuous? Continuous. So again, you don't have to write this off to the side, but just so you know which type it is. So that means we're going to be writing it how we were doing it last class. With the curly brackets, at x such that, y such that. So let's look furthest point to the left, furthest point to the right. If, because we're not using the foldable right now, if you want to, if it helps you, you could draw a line where the furthest point to the left and furthest point to the right are. If you can see it without doing that, that's fine. So what would our domain be? Emmett?
-5.
That's where it would start. Regina? Curly bracket. So notice that this is saying everywhere in between -5 and 6, all the decimals and fractions between that and whole numbers, and not just at specific points. You could do the same thing for your range. Draw in the lines if it helps you see. What would our range be? Otis.
Range is close to highest, correct?
Lowest to highest. Yep.
So our range is y, and the, I forget what it's called, the straight line.
Such that.
Yeah, such that -3 is less than or equal to y, which is less than or equal to 4.
Right. And be careful with this one because it has 2 different points, but you're looking at the highest, not just where this ends. So if one is higher than the other, always look at the highest. Right. X and y intercepts we'll come back to. Is this a function? Yes. Right here it looks a little iffy, like it might, but if you draw any vertical lines, it is not repeat. So yes. Questions on that one? Find example 3. I don't know if that's on the same page. I don't think it is. So on the next page, or the back. Yeah. This should also look familiar. We did some problems like this. Now, the difference between the problems we did and this is that there is a grid line, but it also has arrows. So that's how you will normally see it. I just wanted you to see in general with the arrows. So domain, we're still looking for this left, for this right. It's continuous, so it's still going to be x such that, y such that. For our domain, find this on your reference sheet. Find one that looks similar on your reference sheet. The domain is going to be the same. It's still going out slightly. It's going down, but it's also going slightly left and slightly right, out forever and ever. So how would we write that domain? Austin, I do see your hand. I'm just showing the other people. Austin, go ahead. Because x is an element of all real numbers, or all real numbers. Keeps going forever and ever, left and right. For your range, what's your lowest point? We don't know what that is. It's going to keep going down off the page towards infinity. What's your highest point, though? Landon? 3. And if you want to draw in your highest point, you can. So this is going to be everything below 3. How would we write our range? Jaden?
Y is less than or equal to 3.
Just like that. Is this a function?
No.
Yes. So even though it looks like it might repeat, if I draw my vertical lines, it doesn't. Questions on this one, Otis?
But it does.
This is going to keep going out. So it's never actually repeating. For every x value, there's
Even
always
if it's on
one.
both sides.
Because the repeating y values don't matter.
Oh.
It's for the x values. Alright. I want to say this is back in the staple, but I don't know. Let's do this one first and then that one. So find wherever this problem is. I don't know where that
It's on
is.
the back of page 5.
Okay. Right? If we're looking for this left, for this right, this one has a point for this left. Does it have a point for this right? No, we don't know what it is. It's going to keep going. So if this starts on your y-axis and it keeps going to the right, how would we write that domain? Otis?
Y equals all the
For domain.
Oh, for domain?
Osmond?
X is greater than or equal to 0.
It starts at 0 and it keeps going to the right, so x is greater than or equal to 0. Now, Otis, say what you said again for the range.
Y equals all the numbers.
Not equals, but y is an element of.
Oh, element, that's what it means.
It essentially means the same thing, yes. You can say y is all real numbers or y is an element of all real numbers. Is this a function? No. Everywhere except for on the y-axis, it repeats. Questions on this one? Now find this page. Find the example that looks like this. So we're just going to do 3 more together, and then any you want to see, go over an example on Khan Academy, and then you'll have time to practice. Right. For your domain, we know this is continuous, so we're going to write it as x such that, y such that. What is our furthest point to the left here? It goes forever to the left. What about to the right? It also goes forever. So our domain is what? Otis? X is an element of all real numbers. Yeah. Now what about our range? What is our lowest point? Even though it keeps going left and right, it is not going past -6. And our highest point? -2. So how would we rate that? Notice that these are 2 different things. One is like it's between endpoints, which technically it is, and the other one has arrows to mean it keeps going. Sometimes that will happen depending on the graph. It just look at it. These can be mixed. Is this a function? No. It starts to be on the ends, but everywhere in the middle it repeats. Okay. What questions do we have on that one? I think it's on the back of this. It might not be. I don't know. Find the one that looks like this. For our domain, it's continuous. What is our furthest point to the left? Say that again. Please. Were you raising your hand? Oh, okay. Otis. X is the element over. This is going to keep going to the left and keep going to the right. What is our lowest point for our range? -4. And our highest point? 4. So how would we rate that one?
Y is just the line.
Such that?
Such that -4 is less than or equal to x less than or equal to
X or Y?
I mean y.
Is less than or equal to 4. Is this one a function?
Yeah.
Yes. It just looks weird. Okay. Questions on that one? Okay. And then the last one I want to do together with you. This one. This is kind of like the one where it was like a straight line for our y's, but it's not switched because it's a vertical line. It's still x such that, because it's still continuous. But is our domain moving? No. So what would that be? X equals 2. And what would our range be? Y is all the numbers. Y is an element of all the numbers. Is this a function? No. It is a vertical line, so it can't pass the vertical line test. Right. Look through all of the ones we did not do. Find any you want to see, go over, maybe aren't sure about, want to see, and then
The one next to it.
the circle. Yeah. So I'm just going to star these and then we'll do all of them. Regina? This one. Yeah. Any others we want to see, go over, have questions about? Landon? This one? Any others? Alright, so let's start at this one and then work our way forwards. How would we write, not what is the domain and range, but how would we write it? How would we start writing this? Is it going to look similar to how we've been doing some of these, or is it going to look different? Different, because it's discrete. So we're still going to start with curly brackets, but we're not going to put x such that, y such that. We have to find our domain least to greatest. What would that be? Just once. So -6, -3, 2, and then 4 for our domain. What about our range? Is this a function? No. And what makes it not a function?
Because the x value repeats at -3.
Okay. So you have to know the difference between your discrete and continuous functions. You have to be able to look at these, be able to write them both / pick out the correct domain and range. Right. Find the square one. Rectangle. Right. This is nice because it has definite endpoints. We know the furthest point to the left is going to be here. The furthest point to the right is going to be here. The lowest point is going to be here. And the highest point is going to be here. So what would our domain be?
X straight line, then -5 is less than or equal to x, which is less than or equal to 4.
And what would our range be? Always make sure you count. Don't assume it's going to end up at 5 or whatever. This, before we do the circle one, is this a function? It basically repeats values everywhere. Right? And then find the circle one. This is going to be very similar to the rectangle one. We have a furthest point to the left and right, and furthest lowest and highest point. What would our domain be? Osmond? I did the colors backwards, but. And for our range, what would our range be? Emmett?
-1 is correct.
So how would I write that? It is -1 and 7, your lowest and highest. In the format, how would I write that? This could be anyone. Awesome. Is this one a function? Okay. Overall, how do we feel about domain and range? Good, okay, not good? Let me see everyone's hands. Good, not good, not good. Good, okay, not good. I said not good twice. Great, so I'm going to show you a couple problems on one of the Khan Academies on how you would do this, and then you'll have time to practice. So this is the determined domain of functions. The domain and range from a graph, you're given a graph, so you just have to find which one matches and make sure you're paying attention to what it says. So this one, it only gives you a function. Use Desmos for these. So this, you would just type in the actual function part, not the g of x part. So the square root of x plus 3 is what I would type in. And we are looking for the domain. Zoom out just so you see it. It looks like this keeps going forever and ever to the right. But it starts right here. How would we write that domain in our set builder notation? Otis? Zoom in. It starts there. Starts at -3. Starts at -3. Otis? For our domain. Yeah. So it would be x.
Oh. Oh. Never mind, Mom.
Awesome.
Great.
And this would be, I was going to say greater than or equal to, but it might just be greater. You will see. But When you look at the Khan Academy, it won't be, sometimes it'll be written like that, sometimes it won't. So just look for the one that would match. All values such that x is greater than or equal to -3. So don't try to like do this algebraically or anything, because that's what if you look at the hint/video, that's what it'll have you do. We're not there. We're just doing this from a graph. These ones are weird though. Is it this one or is it another one? I don't know. I'll put this one in and then we'll see x over x minus 17. That did not work. One more time. Minus 7. There we go. Okay. So these are weird because of how it looks. Still zoom out so you can see what is happening at the end. Keep going left and right. It just doesn't go right here. Look at your answer choices. It's saying something about 0, something about 7. If I put both of those in, here we go. And I type in x equals 0, it's going to give me, might give me a vertical line, yeah, okay. And x equals 7. Those two lines will help you see, okay, is there a value at 0? Yes, because they intersect. Here, there's nothing along this line. It looks like it's going to actually touch it, but it doesn't actually. They're just really, really close. So it's not going to equal 7 at all. It's just going to get really, really close to it. So that would be your answer. So if you get problems like that, graph it, look at the answers, maybe put in those answers, see which one it does or does not touch. Yes?
So I noticed that on Khan Academy, a lot of the questions are harder than the ones on the actual test. Is this the same case?
Yeah, because one, all of yours will be from a graph. And we won't be doing any of these. Any other questions, Khan Academy-wise? Regina?
I don't know.
So if I didn't grab your SharkBite answer sheet, make sure it goes in the bin. For the remainder of class, you could be working on these things. The rest of practice from the notes, your Khan Academy that is due tomorrow on the relations and functions, and the 2 domain and range. Let me know if you need my help or have questions. You guys can work together.
Can I use your